just taken 1 day on this section. Not sometimes we take 2, but this one's just a 1 day graph using intercepts. So the x-intercept of a graph is the x-coordinate of the point where the graph crosses the x-axis. Right? The y-intercept is the y-coordinate of the point where the graph crosses the y-axis. So in this graph right here, what would you say is the x-intercept? Right? It's just 3. Right? It's just the number 3. What is the y-intercept? 6. Right? So when they say the term intercepts, plural, they mean both of those, right? X-intercept and y-intercept. Okay. So easy concept. What is the x-intercept? What is the y-intercept? So if you're given a linear equation, and how do we know that 2x plus y equals 6 is linear? This is going to be on the test. It's exactly this kind of question where you have to explain. Why do you know that 2x plus y? I know Connor knows it because he answered it last class. No? Remember, when the x and the y are both raised to the first power, that means that if you graphed it, the graph is going to be a straight line. So, no. Now we're just talking about, I just said, why is that equation linear? It's linear because of that. Okay, so the way you find an x-intercept and the way you find y-intercept, this goes for any kind of function, not just linear. And we end up doing this over and over again in Algebra 2, and we don't always quite get it. When it's not like our common instinct to do this thing. But if you want to find the x-intercept, right, go back to the graph, right? What was the y-coordinate at the x-intercept? It was 0, right? So if you want to find the x-intercept, substitute y equals 0. That will tell you the point, right? So in this equation, 2x plus y equals 6. On the left, right, 2x plus 0, I substituted y equals 0, equals 6. Okay, now solve that for x, right? What property are we using that goes from this line to this line? Identity, right? Additive identity. If you add 0 to something, you get the same thing, right? You don't need to show plus 0. Okay, and then what are you doing from here to here? Divide by 2, right? And so the x-intercept is 3. Okay, if you want to find the y-intercept, you substitute x equals 0. Again, if you go back to the graph, you know, what was the x-intercept what was the x-coordinate at the y-intercept? And it was 0. So that's always the way you find intercepts. You want the x-intercept, substitute y equals 0. You want the y-intercept, substitute x equals 0. 2 times 0 plus, okay? So the 0 plus goes away and y equals 6, right? That was the equation that we graphed on the previous slide, right? So find the x and the y-intercepts of this, right? And I'm going to do this one. So again, what did we just say? We want to find the x-intercept. I should substitute to find the what? If I want the x-intercept, what do I substitute? Y equals 0, okay? And I'm going to step away from my microphone here a little bit. It doesn't really, it's too high up on the screen. Let me do this. But, you know, if you want to substitute y equals 0, right? What is 7 times 0? 0. It's 0. So essentially, when you substitute y equals 0, that whole term goes away. So to find the y-intercept, or the x-intercept, just cover up that term and solve what's left. 2x equals 28. Right? What will x equal if 2x equals 28? 14. To find the y-intercept, substitute x equals 0, right? What is 2 times 0? 0. So essentially, that whole term goes away. So I cover that up, and 7y equals 28. So y equals 4. So when you're finding x and y intercepts, when it's in this is a form that we introduced last time called standard form. It's very easy to find the x and y intercepts. You know, you won't use your whole hand, you'll just use your finger, but cover up one term, solve for what's left. Cover up the other term, solve for what's left. There you go. Okay, so let's see, x-intercept. X-intercept, 2x equals 28, so x equals 14. Y-intercept, 7y equals 28, y equals 4. So find x and y intercepts by substituting 0 for the other variable. So imagine it's a u try. Okay, try to find the x and y intercepts of that one. Okay, quiet, too loud. Right? So again, you just cover up, essentially just get rid of that one term. Like that, find the x-intercept. I didn't write the 5y at all. Negative 3x is negative 15. Solve. X equals 5. To find the y-intercept, don't write the negative 3x term. Negative 15 divided by 5, negative 3. Okay, try that one. Okay, what'd you get for the y-intercept? The y-intercept is negative 5, right? Again, I don't need this here. Just what is negative 2y equals 10? Divide by negative 2, y equals negative 5. Right? For the x-intercept, right, it's going to be, I don't need this one. So solve this. 4x equals 10. So x equals 10 over 4, which is 5 over 2, which is 2.5. Okay. That might be locked. I thought I opened it up. Okay, so quiet please. So in the previous lesson, we were graphing lines by plotting 5 points. The fact is, we don't need 5 points to graph a straight line, right? How many points do you need to determine the position of a line? You only need 2 points, right? And so once you learn something about like the function that you're, Callie? Okay. Once you learn something about the kind of function you're dealing with, then you use that knowledge so you don't have to like go through all the same work every time. I mean, we know now that 2 points uniquely determine a line. That may seem almost obvious, but it's one of those things that it actually goes back to like ancient Greece, where they had what's called Euclid's 5 postulates, a lot of which they're things that you might think sound kind of obvious, but they're the things, postulates, also known as axioms, are things that you accept as being true because you can't prove them in any other way. And then you try to have the minimum number of things that you accept without being able to prove it in any other way, and then prove things on top of that. I mean, another one of these postulates is like this, and you may think this sounds obvious, but here's let's say we've got a line here, right? A straight line. And then here's a point that's not on that line. Another one of Euclid's postulates said there could only be one line that goes through that point and is parallel to the first line. Does that seem like a... What does it mean for 2 lines to be parallel? they're never going to intersect, right? So they're saying there could be only one postulate, or sorry, one line that goes through that point and is actually parallel, means that those two lines would never intersect. That's actually the one that they call as fifth postulate. And actually for millennia, people were trying to prove that actually it could be proven using the other four. And in fact, eventually what they came to understand is it's not only that it can't be proved, it's actually not necessarily true. You know, when you get to geometry next year, everything you're doing is going to be called Euclidean geometry. That's the name of the ancient Greek guy right there. I mean, all of the stuff, you've heard of people like Isaac Newton and Albert Einstein, right? They all dealt with Euclidean kind of things where everything met at nice 90-degree angles, and you could make statements like that and assume that they were true. But when they came up with a different kind of math, non-Euclidean geometry, that's what Einstein used to make the theory of relativity, right? But the fact that there's only one line that you could draw, one straight line that goes through any 2 points, that goes way back when to Euclid. So the thing is, if we only need 2 points to graph the line, then which 2 points? And the truth is, like what we did in the first couple lessons where we were like plotting 5, I mean, you could just pick 2, any 2. But especially if the line is in standard form, the x term plus the y term equals a constant term, then doing this find the x and y intercepts can be a really convenient way to graph the line. So let's say I got this equation. It's a standard form. Remember, standard form is ax plus by equals c. And I need to find 2 points so I could graph this line. Okay, in my mind, I'm going to cover up the y term, solve for x, cover up the x term, solve for y, plot the 2 intercepts, connect with the line. So, for example, what would the x-intercept of this one be?
4.
Yeah, I mean, if you substitute y equals 0, you just get x equals 4. So that's the x-intercept. It goes right there. Right? What will the y-intercept be?
2.
Right? If you substitute x equals 0, you get 2y equals 4, so y equals 2. So there's that. And now you connect them with a straight line. Something like that. So graphing, when you have something that's in standard form by just calculating the 2 intercepts, you know, especially if the math is this easy, then you definitely want to do it. So go ahead, try to graph that one. Find the intercepts, plot the points, connect them with a line. Again, when you find the x and y intercepts, right? Find the x-intercept, cover up the y. If 6x equals 42, then x equals 7. Cover up the x. If 7y is 42, y equals 6. Plot those 2 points.
Could you put a 0 for the x, right? Or xy, 2 points or xy, right? You put a 0 for the x, so you have y equal. So it's 1 point, right? That's your y intercept. Okay, now how about the other one? How about your x intercept?
Okay.
All you gotta do is plot your y intercept. Don't write it like this. This is totally different point. 0, 6, 7.
Okay. If you're given the graph of a line, you should be able to identify the intercepts. Right? There's homework problems like this. So I'm doing this so that you understand the problem, right? What is the x-intercept here?
2.
Oops, that's funny. X int equals 2. What is the y-intercept? -1, right? -1 right there. So here's your U try. You could just tell me right away. X int Okay, so the y-intercept was 2, that's right there, and the x-intercept is -4 right there. I mean, one thing I'm not doing, which I probably should, is just to you know, that's the x-axis, that's the y-axis. Right. And what's left? So last question, last problem. Right, you are helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4, and large tables seat 6. Right, this situation can be modeled by the equation. Okay, do you see where all those numbers show up in that equation? Right, you're seating 180 people, so there's the 180 on the right. The small table seats 4, so there's 4 times x. What do you think x represents then?
Tables.
What kind of table?
Large tables.
Small tables seat 4.
Small.
So x is the number of small. And then plus 6y, well, large tables seat 6, so y must be the number of large. So first we find the intercepts, right? What's the x-intercept going to be? Use your calculator. Use your calculator. Come on, Alyssa. 45. 180 divided by 4 is 45. Okay, what is the y-intercept? Right, that'll be 180 divided by 6, which is 30. So we found the intercepts. Now we got to graph the equation. We said the x-intercept is 45, the y-intercept was 30. So 45 and 30. Okay. Now we have to connect that with a line. I don't like that. That's probably pretty good anyways. Okay, so you graph. And then this is something this book is asking. It's in the homework problem, so you should be prepared for this. Right, it says, give 4 possible whole number solutions. I mean, how many solutions are on that line? I mean, kind of in a way that's, you know, we know a line's made up of infinitely many points, but, you know, we're solving for the number of tables. And the number of tables are not going to be fractions or decimals. They're going to be whole numbers of tables, right? So what we're looking for here in this graph are, but certainly you could have, one possibility would be, well, what if you just said 30 big tables? Right? No small, 30 big tables. That would be 0, 30. Right? You could also have, what if you had all small tables? 45, right? That would be the x. And or try to see, as you look at this graph, some place where the line is crossing the intersection of grid lines, so it's nice even numbers. 20 and 15. Like, how about right there? 15, 20, and where's another one? 30, 10. So that's when they say find 4, they want you to pick out those 4 points. 1, 2, 3, 4. I mean, we don't want to pick like that, right? Because it's in between the intersection of grid lines.
Wait, so that would equal the equation?
Well, that would solve the equation. So these 4, they said whole numbers, right? So whole numbers means not fractions, not decimals. So we could have 0, 30, 15, 20. This one was 30, 10, and 45, 0. You know, again, how do you confirm that? You plug them into the equation, right? The equation, again, was 4x plus 6y equals 80. Equals 180. I mean, we know the 30 and the 45 work, but you could just check. 4 times 15 is 60, and 6 times 20 is 120. So 60 plus 120, 180. Okay, how about this one? 4 times 30 is 120, and 6 times 10 is 60. 120 plus 60. So they all add up. So do you think those are the only whole number solutions in between? I mean, there's the one kind of like flaw in all of this, in the way the problem's set up, is because we only got grid lines at every 5. You know, what if we had grid lines 21, 22, 23, 24, 25? You know, maybe we'd see some more places where they line up. But if you're just going by increments of 5, those are the 4. And that's it. And that's the homework.